This week, a single malicious PyPI release exposed a catastrophic vulnerability hiding in plain sight across the entire ML engineering world. The litellm supply chain attack wasn't a theoretical risk or a red team exercise. It was live, it was real, and it was inches away from becoming one of the most damaging data breaches in machine learning history. If you work in ML, this story is about you. To understand the stakes, you need to internalize one number: 97 million downloads per month. The poisoned release was live for less than an hour, yet in that window, it had the potential to silently exfiltrate SSH keys, AWS credentials, Kubernetes configuration files, API keys, cryptocurrency wallets, and complete shell history from every machine that touched it. That's not a data breach. That's a complete infrastructure takeover at scale. Here's the part that should keep every ML engineer awake at night. The attack wasn't caught by any security tooling, hash verification, or automated scanning system. The attacker's own code had a bug that consumed all available RAM and crashed a developer's machine, which triggered an investigation. Our entire defense was an adversary's coding mistake. That's not a success story. That's a near miss we need to learn from urgently before luck runs out. Andrej Karpathy raised a point that cuts to the heart of modern software philosophy. We were taught that small composable packages are a virtue, that reuse eliminates duplication, that standing on the shoulders of giants is engineering wisdom. And that philosophy isn't wrong, but it quietly transferred enormous compounding risk into every project ever built. When you install a package, you're not just trusting its author. You're trusting every maintainer of every transitive dependency and every account with publish access across that entire tree. For machine learning projects specifically, this problem is measurably worse than in traditional software. A typical production ML service doesn't pull in a handful of packages. It pulls in hundreds of transitive dependencies just to get a model-serving endpoint off the ground. PyTorch, transformers, LangChain, litellm, and their recursive dependencies create an attack surface that most teams have never fully mapped, let alone audited. Every single one of those packages is a potential insertion point for malicious code. There are concrete steps that actually change your exposure. Private package mirrors with pinned, audited releases eliminate silent upstream mutations. Hash verification at install time ensures what you pull down is exactly what was reviewed. And for simple utility functions, Karpathy's advice to use an LLM to write the logic directly and vendor it in-house sounds radical until you weigh it against the alternative. For complex essential packages like litellm itself, pin the exact version, verify the hash, and treat every update as a deliberate architectural decision rather than a background process. The ML community has built remarkably rigorous practices around the things closest to the model: data validation pipelines, experiment tracking, model versioning, evaluation frameworks. But the machines running all of that code have been treated as an afterthought. The real lesson from the litellm attack isn't that open source is dangerous. It's that dependency hygiene needs to become as non-negotiable in ML workflows as a confusion matrix or a data lineage audit. The attack surface isn't just your model, it's everything your model runs on. The litellm incident was a gift in the worst disguise, a near miss that revealed exactly how exposed the ML engineering ecosystem is without requiring the full consequences. The next attacker will test their code before deploying it. They won't leave a RAM consumption bug behind. Luck has already been spent. The window to build real dependency hygiene practices, mirrors, pinning, hash verification, vendor-first thinking, is right now, before the attack that doesn't crash gracefully.